Today we're going to be going over part 2 of the complementary property of trigonometry. Where in this video we're going to be going over the trig of 3 pi over 2 plus theta is equal to the plus minus of cotrig of theta, which depends on the quadrant it lands in, which leads us to the quadrant properties of trigonometry. Within the first quadrant, all 6 of the trigonometric functions are positive. Within the second quadrant, only the sine and cosecant functions are positive. Within the third, only the tangent and cotangent functions are positive. And in the fourth, only the cosine and secant functions are positive. With 3 pi over 2 is seen with a counterclockwise rotation from the x-axis to the negative part of the y-axis, which you can see through the arrow representation along the 3 pi over 2 notion on the bottom of the screen. But to remember and memorize this property, we can look at an example of an angle, which this is for memorization purposes only and should not be referenced to when you are doing this and when you are very familiar with it. But for the beginners, let us draw an angle right here. And let us suppose this angle, and this is for memorization purposes again, as 270.0001 degrees. We can see that it has a very slight nudge to the 270 degrees, but even the slightest nudge, 0.0001 degrees, to 270 degrees, as represented with 3 pi over 2 plus theta, this angle of theta can be as big or large, as big or small, rather, and this time it's going to be really small. It will result and land an angle within the fourth quadrant, which within the fourth quadrant we know only the cosine and secant functions are positive, and therefore we can promptly and surely put negative symbols in front of the other 4 trigonometric functions that aren't cosine and secant. And we do this because, as repeated again, within the fourth quadrant only the cosine and secant functions are positive. And within the complementary property of trigonometry, it states that we must find the cotrig of the trig that we're applying the property towards. So the co of sine is cosine of theta. The co of cosine is sine of theta. So I'm going to draw better. Sine of theta. The co of tangent is cotangent. The co of tangent, or the co of cotangent rather, is tangent. The co of secant is cosecant. And the co of cosecant is secant. And notice, because the cosine and secant functions are the only 2 functions that are positive with positive results from this property, we have the pair of sine and cosecant functions as the positive resultant of the the complementary property with 3 pi over 2 plus an angle. And now moving on to the trig of 3 pi over 2 minus theta. Well, when we subtract the angle, let us assume theta to be an extremely small angle, or rather a small change of an angle relative to 270 degrees. And what I mean by this is, let's say that the angle I just drew there is 269.9999 degrees. Well, we see that we have subtracted 0.001 degrees from 270 degrees to result in this degree. And we see that 0.9999 is an extremely minute difference from 270 degrees, yet it results in an angle within the third quadrant, which within the third quadrant only the tangent and cotangent functions are positive. And therefore, since only the tangent and cotangent functions are positive, we can promptly put negative symbols in front of the other 4 trigonometric functions that aren't tangent and cotangent. As we know, once again, only the tangent and cotangent functions are positive within the third quadrant. And likewise for how we did it for the previous complementary property, the complementary property states we must find the co of the trigonometry function. So the co of cosine, or the co of sine rather, is cosine. The co of cosine is sine, or the co of cosine. The co of tangent is cotangent. The co of cotangent, is tangent. Co of secant is cosecant. The co of cosecant is secant of theta. And this wraps up the complementary properties within trigonometry.